So section 7 is defining rational numbers. Thanks for shutting the door, Jacob. With this, rational numbers are going to pretty much be any number that you've ever used before, with a couple exceptions like pi and decimals that just kind of go on for forever with no pattern. So I'm actually going to jump down here to this part, the rational numbers thing, and fill that in. So numbers that can be written as a fraction are technically going to be rational numbers. And because we can take, and that's a little bit unclear perhaps as far as what can you write as a fraction. So that's why I have this Roman numeral 1, this section up above. But as far as rational numbers, like the number 5, could you write 5 as a fraction? Maybe I should be writing this down in my examples. 5 is a fraction because that's the same as 5 over 1, right? 5 over 1 is just 5. Or if you had like -7, that's a rational number because that's -7 over 1. So any number without a decimal is going to be a rational number. But what about some decimals do work for writing as fractions too? And that's the part up above. So converting decimals to fractions. So terminating, letter A here. So terminating, have you ever seen the old Terminator movies?
Yes.
Terminator stops people, right? Kills them. He terminates them. So a terminating decimal is a decimal that dies. No, it stops. It terminates. So something like 0.21, decimals that stop, they don't go on forever, are terminating. So 0.21 is terminating. 0.438 is terminating. So if you wanted to, you could just write decimals that stop. But decimals that stop, we can write as a fraction. So then they're going to be rational numbers as well. So basically to do that, we put over 10. I'm going to do 10 dot dot dot, where the number of zeros equals the number of decimals. And what I mean by that is I have two decimals here. I have a 2 and a 1. So I have two decimal places. So we write 21 over a 1, and then the number of zeros has to be 2 because we had two decimals. So that's 21 over 100. Fair enough? Questions on it? Or maybe let's do the next one, maybe that'll help. So if I have 0.438, I have three decimal places there, agreed? So we do 438 divided by a 1 with 1,000, a 1 with 3 zeros. Because multiplying by 1,000 technically moves that decimal point over 3 places. Now if we can reduce, that would be good. So this first one, I can't divide by anything even, which is a bummer because that's even. I could divide this by 3 though, right? 2 plus 1 is 3. So, but we can't divide 100 by 3. So this one should be done. So final answer, just 21 over 100. This next one though, because 438 and 1,000 are both even, I usually just divide by 2. If nothing else, that'll get us down to numbers that are easier to figure out. So half of 400 is 200. Half of 38 is
14.
19? 19. And over 500. Now, as long as calculators are legal, you could reduce this with a calculator now that you only have 3 digits in the denominator. Use your fraction key, press equals. But that should be our final thing. 219 is odd, so we can't divide it by 2. We can't divide 500 by 3 because, it's 5 plus 0 plus 0 is 5. So none of the evens will work up here. Yeah, we're done. So, okay for terminating? Repeating. So things like this 0.3 with a line over it, that's really saying 0.3333333 dot dot dot. It just kind of keeps going on for forever. So to write these as a fraction, what we do is we put over 9. So I'm going to just do a 9 with an S after it. Put over 9s, where the number of 9s equals the number of repeating numbers. So 0.3 repeating, I really only have one number that repeats. That 3 just gets repeated over and over. So that's going to be 3 over just 1 9. So 3 over 9. And we could reduce that to 1 over 3. Yep, 1 over 3. Good call, Landon. So divide them both by 3. This next one is 0.21821821828. So we have 3 digits that repeat. So it's 218 over... Nice, 999. And once you're dividing by 9s, so when you're doing these repeating numbers, your options pretty much are going to be divide by 3 or divide by 9. So 2 plus 1 plus 8 is 11. So that's not divisible by 3. So we're done. So 218 divided by 999. Good? Cool. If you could reduce it, you should. So rational numbers, they're going to be numbers that can be written as a fraction. So we already talked about things like 5 would work and -7 would work. But we also are going to have, because of what we just did, includes decimals that repeat or stop. And for that stop, I'm going to say terminate. Got to squeeze that in there too. So at least I've used the right term, even though it maybe doesn't make as much sense. So if you wanted to, you could put examples down below, like, I don't know, maybe a 0.7 repeating, or a 0.14, or, just make up some numbers if you want. So, feel okay for rational numbers? Cool. So rational numbers, all numbers with no decimals, all numbers with decimals that stop, all numbers with decimals that repeat. And kind of the example of things that aren't, if you're going through trying to say if things are rational or not. Pi is an irrational number. They haven't found a pattern to it. They haven't found an end to it. So that's going to be one. And you guys remember doing square roots last year? Yeah. Some yes, some no. Like some square roots. Like square root of 4 is saying what square root is 4. So the answer is 2. So that's rational, right? 2 is a rational number. But some square roots, like square root of 2, if you punch that into your calculator, you'll see kind of like a random string of numbers. You don't notice any repetition, and it doesn't stop for the end of the screen. So then you just assume it's rational if you don't notice a pattern and it doesn't stop. So if you wrote this stuff in green, I'm not sure it should be a part of your notes, but I'm going to at least write not rational. The technical term is going to be irrational, but as you're doing your homework, when you see things like that, those are going to be the ones that aren't rational. So. All right, ready for Roman numeral 3?
Yeah.
Cool. Last section. So comparing numbers, basically we're looking at, are numbers bigger than each other? Are they smaller? Put them in order, that type of thing. Used to do these on those RTI tests we did. So if you have fractions, I like letter B better, to change them to decimals. That's especially nice if you're allowed to use a calculator and you can just punch it in and get the decimal. But if you need to keep it as a fraction or you can't use a calculator, probably the best advice is change to common denominators. So for these, we could go through and essentially we're trying to find what's the least common multiple of 3, 4, and 5. So a couple ways you could do it. You could say, well, least common multiple of 3 and 4 is 12. So multiples of 12 are going to work. Least common multiple of 12 and 5. What's 12 times 5?
60.
60. So 60 will work. It might not be the smallest one, but 60 would work. Otherwise, you could go back and if you do factor trees, you agree this is just going to be a 3. This is just going to be a 5. This here is going to be a 2 squared. So now you multiply what any of them have. So it'd be 2 squared times 3 times 5, which also then gives you 60. So anywho, so find a common denominator somehow. But if we're going to go with 60, 3 times 20 gives me 60, right? So I multiply 2 by 20 and I get 40. So 40 over 60 for that first one. My second one, 4 times what gets me 60? 4 times 10 is 40.
15.
I need half of 40 more, so yep, 15, good call. So you could always take your calculator and do 60 divided by 4, and that would give you 15. So I need to multiply top and bottom by 15, so I get a 45 over 60. And our last one, 5 times 2 is 10, and I need 6 of the 10s, so 6 times 2, 12. So I get a 36 over 60. You okay for those? So smallest one is
36 over 60. Which
nice.
Is 3/5.
Yep, if you cut a ginormous pizza into 60 pieces, you get 36, you got robbed. So next biggest would be 40. Then last is the 45. So if we want to put them in order, we should go back and use the original numbers there. So 3/4 would be the first one. So 3/4 is the smallest, 3/5, my bad. So 3/5, this one here is the smallest. Second smallest is 2/3. And then our third one in line is 3/4. So, questions on that?
Oh, that's on the side.
Yeah, the other side I like better though. So, no idea. So, all right. The last page. I like this better. Maybe some of that comes with having done math more. You just know more of these in your head. But you could always, to change a fraction to a decimal, divide the numbers. So divide the numbers. So in other words, if you take your calculator and do -1 divided by 3, you'll get -0.3 repeating. So it'll say -0.333333. If you take 1/4 as a decimal, that's going to be 0.25. I lost you from the banging on the wall. So, no idea. So for these, if you notice, the book I think is the same as those RTI tests we had. When you get these questions on the RTI test, at first, my first year or two, it was like, seriously, that's hard. But they actually make it easy if you notice the pattern. Do you agree positives have to be smaller or negatives have to be smaller? Negatives. Negatives are always lower than positives, right? So they'll give it to you in like pairs of numbers that are close. So those two have to be my first two. So which one is smaller? Is -0.3 smaller or -0.333333? Which one's more negative or more on the left of a number line?
0.3. No, 3.
Yep, the 3 repeating is going to be more negative. So -1/3 is going to be first.
Oh, yes.
And then second, yeah, it's kind of which one's bigger? Which one's more negative? Which one's further left? So then -0.3 is going to be my second one. So right away we can just take the two negatives. We know those two are going to be first. Figure out the order. Then we get rid of them. Of my next three, usually when they give you the next three, one of them is going to be different than the others. Either it'll be way bigger or way smaller. Who sees which one has to go next?
0.
0. Agree the 0, same as there in the middle, has to be next?
Why not?
1/4.
Because this is kind of the boundary between positives and negatives. So 0 is going to come before any positive number. Might be kind of hard to see there squeezed in the middle, but so 0 is gone. And now next we just say what comes last. Is 0.3 larger or is 0.25 larger?
0.3.
Yeah, 0.3 is the biggest one. Maybe I should have asked it in the other order. So biggest will come last. 0.25. Oops, I probably should have wrote that as 1/4. So I'm going to change that back to 1/4. So 1/4 then would be last. So if you could write the original numbers from this line as opposed to the decimal approximation, I'd appreciate it. But questions? Seem okay? Yep.